topic of this video is determining the inverse of a function, and the specific subskill, verifying two functions really are inverses of each other. Let's look at a problem. A student solved a problem. She was given f of x equals x cubed plus 7. She determined that f inverse of x equals the cube root of the difference x minus 7. Prove she is correct. Okay, to prove she is correct, we must show that f of f inverse of x equals x, and, swapping the order, f inverse of f of x also equals x. Let's begin. We're going to focus our attention on the left side. We're going to temporarily ignore the equals x part of this. And we're just going to figure out what is the left side equal to. In fact, for a moment, I'm going to just temporarily erase the equals x up here, and I'm going to put equals x down here at the bottom, so that we can show that when we figure out what this equals, at the end, it will equal x. Okay, so here we go. Clearly, we are composing two functions together, and because our innermost item here is a variable, we work from the outside in. So that means we start with function f, and specifically the right-hand side of function f. But every time we see x, we put f inverse of x instead. So we get f inverse of x cubed plus 7. That's the right-hand side of the function f, but in place of x, I put f inverse of x. All right, now I'm going to attempt to simplify. F inverse of x is given here as the cube root of x subtract 7, but f inverse of x is being cubed. And when you cube a cube root, they cancel each other out, leaving you your radicand, x minus 7. So we have x minus 7 plus 7, the 7's cancel, and we get x. X equals x, and it checks. We are halfway done with this problem. Now we swap the order. So we're composing the two functions, and once again, we are going to pay attention to only the left-hand side of this statement. Just as before, I'm temporarily going to erase this equals x and move it down to the bottom. We're going to work only on the left side and show that when we find out what it is, we get x at the end. Let's begin. We are composing two functions. The innermost item is a variable, so we work from the outside in. Only this time, the outside is f inverse, which means we are going to take the right-hand side of f inverse as our next line of algebra. But everywhere we see an x, we put what's in here, which is f of x. So we get the cube root of the difference, f of x, subtract 7. Now substitute. In this problem, f of x equals x cubed plus 7. So we get x cubed plus 7, then the subtract 7. We must combine our like terms before we take the cube root. Plus 7 minus 7 cancels, leaving us the cube root of x cubed, which conveniently equals x. So once again, we've showed that the two sides are equal. X equals x. By going through this process, we have proven that the student's work is correct. Now, the most common mistake that students make when they are doing problems of this type is they take one of their functions and then they go through the 4-step process to show that the answer is f inverse. That is not a valid approach for solving problems of this type. If you are ever asked to prove that a function and its inverse truly are inverses of each other, you must compose both functions together in both orders and show that you get the result x each time.